it is also called torque. So moment or torque can be defined as, its simplest definition is its turning effect of force. Let's suppose if you have some object or some rod that is placed on a ground and it is fixed at this position, and if you apply a force on it at this position, so it will start moving like this, clockwise. So this turning effect is called movement. Okay, so in movement, two factors play the part. First factor is the force that you have applied, and the second factor is the distance between this fixed point and the point of application of force. This is distance t. So moment depends on two factors. One is force applied, and the second factor is the distance between the force and fixed point. Okay, this fixed point is also known as pivot point. Okay, so pivot point can be defined as, we can define pivot point as a point about which the body will rotate. Okay, so it's a fixed point. So writing down its mathematical expression, we can define moment as, moment is equals to force multiplied by perpendicular distance between force and pivot point. Okay, and this is moment is can be represented by a symbol m, or force can be represented by f, and this distance can be represented by a d. Okay, so m is equals to ft. We can define it like this. Okay, so its units are Newton meter. How? Because force is measured in Newton, distance is measured in meters, so moment will be a product of Newton and meters. Okay, so units of moment is Newton meter. It is the SI unit. So there is a principle of moment that is very important to solve any numerical problem. Principle of moment. So principle of moment told us that if the sum of all clockwise movements is equals to sum of all anti-clockwise movement, then object will not rotate. So this condition is called rotational equilibrium. It's mean the object will not rotate in any direction. Okay, what are the possible directions for the movement? So movement directions are, first is directions of movement can be clockwise or it can be anti-clockwise. Okay, so if we consider the clock, there is 12, 1, 2, 3, 4, 5, 6, 7, 8, 11. And let's suppose there is a needle. So the needle, if the needle is at this point, it will move in this direction. So the direction of clock is known as clockwise movement. Okay, this is clockwise movement. And if we consider the clock, if we just imagine it, 4, 5, 6, 7, 8, 11. So if there is a needle at 12, and if we move opposite to the motion of clock in this direction, so that will be anti-clockwise movement. Okay, so these are the two possible directions. One is clockwise, and in the opposite direction to the clock is called anti-clockwise movement. Okay, so if we consider in a practical scenario, let's suppose we take a example of seesaw. There is a plank that is placed on some support. Okay, so it is placed on some support here. This is the point about which the body will rotate. So this point is known as pivot point. It can be anywhere. Okay, it's not mandatory that it will be at the center. It can be anywhere. So this is the point where the body is fixed, about which the body will rotate. So let's suppose there are possibilities where we can apply force. We can apply force on the right side, downward direction. Let's suppose this is F1. We can apply force in the upward direction as well. On left side we can apply force in the downward direction. Let's suppose this is F3, and we can apply force in the upward direction as well. Okay, so we have to check in which direction these forces will produce movement. Okay, we are only interested for this movement in the direction of movement. Okay, so let's suppose let's discuss for F1. So considering F1, the pivot point is on the left side. This is the pivot point, this is the force. So if we extend this arrow from F towards the pivot, this will make this type of direction. Okay, so this is the clockwise movement in the direction of clock, if you consider the previous diagram that I have made. So this will produce clockwise movement. So force acting on the right side of the pivot point down in the downward direction will produce clockwise movement. And if we consider F2 is the force that is on the right and acting upward, right of the pivot point. Okay, so it will, if we extend this arrow towards the pivot, it will produce a force movement like this. This is anti-clockwise movement. Okay, these are direction of movement. And if we consider F3 is on the left side of the pivot point and it is acting downward. So if I produce the arrow towards the pivot point from F3, it will be anti-clockwise. And for F4, it toward the pivot, it will be clockwise movement. So these are the possible directions of movements. So if the force is acting on the right side in the downward direction, it will produce clockwise movement. Or if it is acting on the left side upward direction, then it will produce clockwise. So there are two possibilities: right side in the downward direction force. Okay, right side of the pivot point and force acting downward, it will produce clockwise. So if I highlight clockwise movements, this F1 is clockwise and this F4 is also clockwise. Okay, so these are the two movement forces, those are producing clockwise movement. Talking about anti-clockwise, F2 and F3, they are producing anti-clockwise movement, and this is producing clockwise movement. Okay, so these are the possible directions of movement. So how we can solve the problems? Basically, you will have some scenario. Let's suppose we have let's solve one question. Let's suppose we have a scenario that there is a seesaw or a plank that is placed on some support. It is attached there. Okay, and the total length of this is the pivot point, and there is some weight attached with it. Let's suppose it is 100 Newton, okay, and there is another weight attached with it, and its weight is, let's suppose it's unknown, okay, we have to find it. And the distance from this to the pivot point is 5 meter, and from this to this is, let's suppose it is 7 meter, okay. And this is a problem, and given is if rod is not moving, find w, find weight, okay. So it's in the equilibrium state. So let me show you what we have discussed about principle of movement, that the sum of all the clockwise movement must be equal to sum of all the anti-clockwise movement. We have to apply this law because there is a rotational equilibrium, it is not rotating, okay. So sum of all the clockwise movement is equals to sum of all anti-clockwise movement. So let's see, there are two forces. First of all, we have to identify the pivot point. So this point is a pivot point, this is pivot, and there are two forces. Let's suppose this force is F1, this is weight, this is the second force, weight is also force, okay. And we have distances. Let's suppose this 5 is D1, this 7 is D2, okay. So let's decide which one is clockwise and which one is anti-clockwise. Weight is acting downward on the right side of the pivot point, so it will produce a clockwise movement, okay. And F1 is acting leftward in the downward direction on the left of pivot point in the downward direction, okay. So it will produce a anti-clockwise movement, okay. So applying principle of movement, what it is, sum of clockwise movements is equals to sum of anti-clockwise movements. So clockwise movement is, we know the formula of movement was, let me show you again what we have. This is the formula for the movement. Movement is force multiplied by distance. Which distance? It is a perpendicular distance between the force and the pivot point, okay. So for clockwise movement, what we have force is, it's F1, sorry, clockwise is weight, so force is W, and the distance of this force from the pivot point is given here, it's 7, so it will be W into 7. And the anti-clockwise movement force is, we have 100, and the distance from it, that is 5, so it will be 100 into 5. So weight will be 100 into 5 divided by 7, and the answer will be in newtons, okay. Sometimes they will ask you, so this is the final answer, okay. Sometimes they will ask you a tricky question in which you have to identify yourself the distance from the pivot point to the force. Let's discuss another problem. Let's suppose you have a scenario in which they have given a total length of the rod. Let's suppose the rod is from this point to this point, it's 10 meter. Let's assume it's the value, and it is, let's suppose it is fixed at this point, okay. This is its fixed point. So there is a force that is acting on it in the upward direction. That force is F, and there is a weight of weight of this rod is equals to, let's assume it's 150 Newton. Okay, so what we have to do in this, the weight will always act in the mid, so weight will be at the center of the rod there. Okay, so what we have to do, we have to find if rod is in equilibrium, find F. Okay, so we have to apply, for solving this we have to apply principle of movement. So clockwise movement is equals to anti-clockwise movement. Clockwise movement is basically due to this weight, and the anti-clockwise movement is due to this force. They should be equal. So for this weight, the distance will be considered from the pivot point. This is the distance. If the total length is 10, this will be half of it. So 10 by 2 is 5. So for clockwise movement, force is weight multiplied by the distance between the force and the pivot point is 5, is equals to anti-clockwise movement, force is F, distance is 10. Weight is also given, that is 150. So 150 into 5 is equals to F into 10. So I can write it as F is equals to 150 into 5 divided by 10. That will be your final answer in newtons. Okay, so this is how we can solve the simplest questions. We will try to practice some more questions from the past paper in the next video, so make sure you subscribe and like the video so you get notification when I upload the next video on the past paper questions. Okay, see you in the next class. Thank you.